Hello everyone, this is Yali Wang. This video is for solution 2 of homework 9 of EL 6303. For this question, we know the Poisson process with a parameter lambda. So we define a new stochastic process as x of t equals 2 if n is odd in integral 0 to t. X of t equals minus 2 if n is even in 0 to t. So question A, we need to draw a couple of samples. Question B, we need to find the probability of x of t equals 2. Question C, we need to find the expected value of x of t. Question D, we need to find the R function. Question E, we need to make sure if x of t is WSS. So first we can draw the samples. So we can see it's a telegraph. Question B, we can find that the probability of x of t equals 2. It equals the probability of n is odd in integral 0 to t. So we can get the probability of x of t equals 2. It equals probability of 1 plus probability of 3, probability of 5. So we can get it equals the sum. So through the calculation, we can get it equals e to power minus lambda times t2 minus t1 times e to power lambda times t2 minus t1 minus e to power minus lambda times t2 minus t1 over 2. We can simplify it, so we can simplify it, so we can get it equals half of 1 minus e to power minus 2 lambda times t2 minus t1 minus t2 minus t1. So similarly, we also can get the probability of x of t equals minus 2. It is the probability of a is even in 0 to t. It equals half of 1 plus e to power minus 2 lambda of t2 minus t1. And then we need to calculate the expected value of x of t. So it equals 2 times 1 over 2 times 1 minus e to power minus 2 lambda times t2 minus t1 minus 2 times 1 over 2 times 1 plus e to power minus 2 lambda times t2 minus t1. So it equals minus 2 times e to power minus 2 lambda times t2 minus t1. So D, we need to find the R function. So we note that if t equals t2 minus t1 is greater than 0 and x of t1 equals 2, then we can get x of t2 equals 2 if the number of points in t1, t2 is odd. So we can get the probability of x of t2 equals 2, given x of t1 equals 2, and it equals e to power minus lambda t times e to power lambda t minus e to power minus lambda t over 2. So because we know the probability of x of t1 equals 2, it equals e to power minus lambda t1 times e to power lambda t1 minus e to power minus lambda t1 over 2. So we can get the probability of xt1 is 2 and xt2 is 2. It equals e to power minus lambda t times e to power minus lambda t1 times e to power lambda t minus e to power minus lambda t over 2 times e to power lambda t1 minus e to power minus lambda t1 over 2. So similarly, we can get the other equation. We can get the probability of x of t1 equals 2, x of t2 equals minus 2, and the probability of x of t1 equals minus 2 and xt2 equals 2, and the probability of xt1 equals minus 2 and x of t2 equals minus 2. So since the product xt1, xt2 equals 4 or minus 4, so we can conclude that the R function equals e to power minus 2 times lambda times the absolute value of t1 minus t2. So for question E, because we know the expected value of xt, it equals minus 2 times e to power minus 2 times lambda times t2 minus t1. It's not a function, it's not a constant, it's a function about t2 and t1. So x of t is not WSS. That's it. Thank you.